Exams Eds. As we progress from one session to the other, learning more about each type of soil, I'm glad that at least this brief education in soil is included in our ICSE syllabus, as this is the need of the hour. What I mean is that this little awareness that we get will help us care for our soil and heal our environment. We are a part of this environment, so we need to care for it if we really value our lives. Directly or indirectly, we all depend on the soil in our locality, and we know how important it is for our survival. The future of our little planet Earth is in your hands, the young generation. Good luck! In the previous sessions, we learnt about two rich soils, the alluvial and the black. In the next sessions, we will get to know more about two poor soils, the red and the laterite soils. What is meant by rich and poor here, you may be wondering. Well, all I meant is the level of fertility of these soils. Alluvial and black soils are more fertile or rich when compared to red and laterite soils. By now, you have an idea of the pattern in which we make a study of these soils. Based on that, we begin with the formation of the red soil. It is formed by the weathering of ancient crystalline and metamorphic rocks. Reminded of the 9th standard portion of rocks in the lesson Materials of the Earth's Crust? Yes. If we can relate our studies with what we have already learnt or seen around us, learning becomes very easy. That's why I like to make such references. I wish to stress on 3 terms here: crystalline, metamorphic, and ancient. We already know that some metamorphic rocks occur in crystalline form. Metamorphic rocks are harder and more resistant than the original rocks from which they are formed. That means they don't break up easily, but due to continuous weathering for many years by agents like rainfall, very old metamorphic rocks break up to form red soil. That's why the term ancient is used. One particular nature of this soil is that it differs from place to place depending on the parent rock material, that is, the rock from which it is formed, and on the climatic conditions of that place. When we make a study of the characteristics of the red soil, first, we will check out its physical properties of color and texture. In color, it is named after the dominant color in which it is found in most places, that is, red. It gets this color from the high amounts of iron oxide content. But in certain places, its color changes slightly and it appears in a chocolate brown or grey shade. Wherever this soil is in hydrated form, that is, it has moisture present, it will be yellowish. In texture, the red soil is porous, clayey, and friable. Dry farming methods can be practiced. This condition is found in regions of scanty rainfall where the soil occurs. The lowermost area of red soil is dark, clayey, and fertile, while the uppermost layer of this soil is sandy and porous, so less fertile. With proper irrigation, it can support the cultivation of many crops. Here, we can move on to the study of the chemical properties of red soil. This soil has a high content of iron oxide. It is rich in potash. Its pH ranging from neutral to acidic. It is poor in nitrogen, phosphorus, potassium, lime, and humus. This makes the soil less fertile and is disadvantageous. When fertilizers are added, the soil responds very well and becomes more productive. Next, where do we find the soil in India? Let's check the distribution chart and also make a reference study with the map. Learning with a reference map helps you to register details very quickly and understand them well. That's why you find so many maps and illustrations in your textbooks. If we take a close look at the areas where red soil is found, we will see that it occurs in the plateau region, almost surrounding the major areas of black soil, extending towards the south, and is distributed in the eastern end of India too. It covers large parts of Tamil Nadu, Karnataka, Telangana, Andhra Pradesh, Odisha, Chhattisgarh, Jharkhand, Bundelkhand, Meghalaya, Mizoram, Manipur, and Nagaland. Scattered patches are also found in West Bengal, Uttar Pradesh, and Rajasthan. That was quite a long list. Red soil occupies such a vast area as it is the second largest soil group in India. To the last section, the crops grown in red soil. It is suitable to grow almost all types of crops with proper fertilization and sufficient irrigation. Moreover, the difference in the texture of soil in the upper levels or uplands and lower levels or lowlands makes slight change in the types of crops that can be cultivated in such areas. So, wheat, rice, millets, ragi, pulses, vegetables are all suitable to be grown in this soil. Groundnuts and potatoes can be grown on the sandy and coarse soil in the uplands, while even cotton and sugarcane can be grown in the lowlands where the red soil has more of clay content. That's the end of this session. We have only one more soil to go, the laterite soil. Before we conclude, I feel that one small activity will be very beneficial for you to understand the terms moisture retentive and dry farming. For this activity, we need 3 similar types of mugs or cups filled with 3 samples of soil that you find in your area. Even coconut shells can be used. Let's learn to be eco-friendly. Soil in the backyard, gravel, sandy soil, soil beneath the grass, any 3 types that you can find in your home premises, near the gate or beside the road can be taken as the 3 samples. Soils of bigger grains or texture can be sample 1, medium-sized soil can be sample 2, and fine or tiny grains of soil can be sample 3. Even 2 types of soils might be enough. Pour half a cup of water into the first soil sample, another half cup into the second sample, and likewise half a cup of water into the third sample soil. Please note, the amount of water that we pour in each soil sample should be the same. Also, make sure that you pour it gently to avoid spilling the water and thus going wrong in the calculation. Next, we are going to gently tilt sample soil 1 and pour the water back into the water cup. We have to make sure whether the water is equal, almost equal, or less than the original amount that was poured into the soil sample. Do the same with the other 2. We will notice that sample 1, having bigger particles like gravel or stones, would give back almost the exact half cup of water that we poured in it. The second sample with medium-sized grains will give back lesser quantity of water than the first. The third soil might give back very little water, having fine grains or a clayey nature. Here, you will find that the second sample retains water. It has clay content, and at the same time, we find sandy grains also. But sample 3 has given me more of water. Coarse grains are almost absent in it. It is mostly clay, and it retains more water. The clay content of the topsoil or subsoil can retain moisture to be used in dry conditions. Don't forget to wash your hands clean with soap and water. Sample soil 3 is highly moisture retentive as it has very fine particles or clayey particles. That water retained in the subsoil will help in the growth of crops which do not need much moisture. This is called dry farming technique. So, have fun, love nature, learn from nature, and become more environment friendly. Bye for now.